Well, welcome back to day 3. Hopefully, we're getting the hang of all the TDD that's going on here now. And so without further ado, let's just go ahead and jump right in and start reading our problem. Day 3. Our computers are having issues, so I have no idea if we have any chief historians in stock. Welcome to check the warehouse, though. Any chance you can see why our computers are having issues again? Computer appears to be trying to run a program, but its memory, the puzzle input, is corrupted. Okay, seems like the goal of the program is just multiply some numbers. It does that with instructions like mul xy. Xy are 1 to 3 digit numbers. So for instance, mul 4446, okay, sure. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mul instructions. For example, yep, stars, exclamation points, question mark, spaces. Okay, so none of those are allowed. Okay. Here is our sample input. Let's go grab this because, as you'll find out, turns out I might not have the right sample input to begin with. I do. Okay, good. All right, let's go back. Only the 4 highlighted instructions, mul 24, mul 55, mul 118, mul 85. Multiply them, add them together, you should get 161. And then here's our answer for the big version. Okay, so you might have known what I was going to do here based on the fact that I already have a tab open, but my approach for this is a regular expression. So we're going to go ahead and throw this input in our regular expression tester. We'll be right back for it though, because first let's figure out exactly what it is we want to do, right? So we have to read an instruction from the file. Okay, right? We look at the full set of data, we can see that we have multiple lines of instructions. So we're going to need to read instructions line by line from the file. Going to need to find valid mul xy, where x and y are 1 to 3 digit ints. Add all the valid multiplications. And that will be our result. So probably the things that I want to do, the first thing I want to do is actually this, I think, right? Given a single line, what is it that I can find in it and multiply out? Let's go with public static class computer. I think that's twice we've used computer now. And we're going to say static int, let's see, evaluate string instructions. Okay, so given this, let's go ahead and return 0 from this, right? What I really want is to be able to read all these line by line and validate them. But first, we'll TDD the evaluating a single line into being, right? So let's say public class computer tests. And let's say public void can evaluate, let's see, can evaluate single mul. All right, let's start easy, right? Let's say var result is computer evaluate x mul 1 to y. That's about as simple as we can get. We've got garbage on the other side and 1 multiplication, right? And then we know that the result should be 2. Okay, let's go ahead and run this. We know this is going to fail, of course. Oops, that's not what I wanted. That's what I wanted to do. Okay. Oh, we've got all of our other tests. Let me go comment all of our other tests, or skip these, sorry. Oh, I feel like I'm misaligned on my keyboard here. New keyboard. Got a 75% keyboard. I've been using a 10 keyless for a long time. And the alignment of things is really sort of finicky for me right now still. Okay, So expected 2 got 0. Yep, that makes sense. We haven't implemented anything. So if I were to look at this and say, if I wanted to parse this by hand, we would obviously start looking for M's. And then when we found an M, we'd look for a U. When we found a U, we'd look for an L. Then we'd look for a parenthesis. We'd look for 1 to 3 digits. We'd look for a comma. We'd look for 1 to 3 digits. We'd look for a parenthesis. Anything outside of that, and we would fail. Now, I already mentioned that I really want to use a regular expression here. So let's actually take this over to our regular expression tester. Let's take that out for the moment, right? So first thing I could do, I can obviously look for mul, and you can see we're going to see MUL. Now, if I open a parenthesis, it's going to say not enough parentheses. That's because parentheses is a special character in regular expressions, so we have to escape it, right? And then we want a digit. So one way you can do a digit is you can say 0 to 9. That's a digit. But there is a shortcut for that, and /d is digit. Now, we want between 1 and 3 digits, but as it turns out, we don't have tests for that yet, so we don't need that yet. A comma and a digit, and then a closing parenthesis. This looks like a good enough regex to get started. Okay, so let's go over to our code. So I guess I have a Visual Studio update. Nice. All right, so let's say static regex, mul regex. And we'll put this in here like this. Oh yeah, we need new, obviously. Okay, so then we're going to say result. We'll start at 0, then we will return the result, right? And then we'll say the match is mul regex.match on the instructions. If the match is a success, then what we're going to do is we want access to these values. So we actually want to use parentheses to group things where we want the value. So that's a value we want, and then that's a value we want. And if I come down here and look at the table, what we'll see is we've matched, and then here we say, whoops, I put the parenthesis in the wrong place. Why you look at this stuff. The values we're going to get out of this are 1 and 2. And they're in groups 1 and groups 2. That's how those things get exposed in C#. So if it's a success, then we're going to say result gets int parse of match groups 1 value multiplied by int parse match groups 2 value. Okay, that easy. Does our test pass now? Our test should pass now. Input string empty was not in a correct format. Who in what? Int 32 parse. We didn't have groups of 1 and groups of 2. Okay, that's weird. Well, let's go ahead and take a look in here. Let's see what happens. Maybe I'm misremembering how to get at this. Levels. Okay, that was watches from yesterday. So our match here, we've got groups. Oh, so groups is not what I was looking for. I don't think. All right. So let's look at match. Captures, is that what it's called? Oh, I thought it was groups. Oh, of course. We didn't update this. I did it over in the regex tester. I didn't do it here. Yep, that makes sense. Does it pass now? Okay, that's better. That's what I expected. So far, so good. We've got a test that we can do a single mul. Now what happens when we want to do multiple muls, right? So multiple mul. And now we want to just go ahead and take our actual data here, because this is good enough. This is how we're going to get multiple muls out of here. So this is our test data. And we know that the answer should be 161 because, of course, that's what we were told. And so we have 2, 4. This is not good. This is good. We have 5, 5. This is not good because of the closing square bracket. This one is good. And then this one is good. So we're going to have 4 of these. So let's go take this over here and see what happens if we do this in a regex tester. Well, that's interesting, right? We knew we needed multiple digits here, up to 3 digits. So it's now time to do this. So what we can do is we can say digit. Now that matches this, but not the rest. So we put a question mark on this to say, yeah, that extra digit is optional, just like the 3rd digit is optional. So we'll put that there. That's going to match all 4 of these. So now, given this regex, what it looks like is we have multiple matches, right? Now each with a 1 and a 2. So instead of matching just for 1, we're going to match for multiple. We'll go ahead and change our regex up here. That's going to match for multiples. So what we can then do instead is say match in mul regex.matches for the instructions. And now every match in there will be a success. There's no reason for me to actually check that. And here we can say match groups 1. Object does not contain a definition for groups. Okay, so this is a weirdness in the fact that regex is a very old class, right? This matches definition is a match collection, and a match collection is just, it's like an IList of match and I read-only list and IList, but at the end of the day, it doesn't really understand that this thing is supposed to be a match. So we can just tell the compile, by the way, this is a match. Okay, and now our groups, we don't have squigglies anymore. Let's run our test and see what happens. And there we go. So this looks like it's good enough to pass our test. So what's left here? We've got this already. Add all the valid multiplications. So we've got both of these. So then read instructions from the line by line from the file. That doesn't feel like a production code thing. That feels like this is part of our test here. So let's do this. For each var line in file.read all lines of the file name, right? We're going to do result plus equals computer.evaluate the line. Okay. So now if I run these tests, we're going to get, hopefully, passing tests. Okay, so that's good. So that's how we got ourselves to this. I don't know how big this number is because I didn't put these in here. 168 million. So another thing to keep in mind here is that we aren't quite yet to the point where we would have needed to use longs instead of ints, but that'll definitely be coming up later. But that's also something for you to think about in a design of this is how future-proof does this need to be in terms of being able to run all of these things. So one of the things you can do is you can put a clause around here to say that you want to have this code be checked to make sure that there's no overflows, right? So this block will basically say, if we overload int, this is now going to throw. Without a block like this, the overload of int's just going to wrap around back to the negative half of ints, and you could come up with a negative number, which might be a hint that you had a problem, but also you could end up with a positive number that's just outright wrong. So adding this check line here is helpful, but that's not the only place where we would need it, right? We also would need it here because we're also doing an addition here on the result. Okay, so that's just a little bit about checked. We don't actually need those today. We know we don't need those today, at least so far. So let's go ahead and remove those out of here because that's something we don't necessarily need yet, but it's something for you to think about for your future code. All right, so let's go ahead and look at what's going on here with part 2. Okay, part 2, as you scan through the corrupted memory, you notice some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. So there are going to be do and don't instructions. Only the most recent do and don't instructions apply. At the beginning of the program, mul instructions are enabled. Okay. So here's the first time we've seen this, which is pretty early in advent of code, where they've actually changed the sample data underneath us. So I'm going to bring this new sample data here, and I want to show you how it looks compared to the old sample data. You know what? I did not have the old sample data in there. That was my mistake. This is the old sample data. Interestingly, as it turns out, the old sample data and new sample data give me the same thing. It's just they've changed a do not into a don't over here. And then they've added this undo, which actually, as it turns out, is actually do, right? Because we're going to ignore the un. So there you go. There's the new data. We got to keep an eye out for that because that sometimes does happen. Okay, so corrupted memory is similar from before, but this time the mul 5.5 and mul 11.8 are disabled because there's a don't instruction before them. The other mul instruction functions normally, including one at the end, it gets re-enabled by a do. This time the sum of the results is 48. Okay, handle the new instructions, and here's the big number as well. And so let's go over here. First of all, let's make sure our big number isn't going to be too big. I'm pretty sure it won't because we should end up with a lower number. We do. Okay, so time for this. And the answer on this is we need to have a different computer evaluate here, right? Because obviously if we have one evaluate that does both, then in the case where the don't and the do end up in here, we end up with a different answer, right? So what we want now is we either want a different version of evaluate or we want one that takes a flag to say, should we pay attention to conditionals? Can evaluate multiple mul with conditionals. Let's start by assuming evaluate with conditionals. Let's do this. And we know that the answer is going to be 48. Right, so we'll go ahead and do 48. Even before that, we can do, let's say we could do something simpler. We could do this one again. I'm not sure that that buys us a whole lot. Let's come up here. Let's make another one of these. Evaluate with conditionals. Okay. And if we have as a starting point, I mean, obviously as a starting point, we can just return 0, and that's going to fail, of course. I unskipped down here, which we don't want to do this yet. I want to go ahead and leave these out of the way for the moment, right? So that we can focus on the one thing that's important here. Obviously 0 is wrong. And just returning 48, we could obviously do that and force ourselves to write another test, but we're just going to go ahead and skip that today. We saw us doing that yesterday. So what we really need, though, is given this regex, we obviously are only looking for muls. We're not looking for do's and don'ts. So one of the things that's interesting about this is everything in a regular expression gets matched in order. So if we could just come up with one regular expression that matches against everything, then that would work for us too, right? So the OR operator allows us to do that. So we can then say we're looking for do, right? Or we're looking for don't. So now if we look at the table, what we'll see is we're going to get 6 matches now. We've got the mul, the don't, the mul, the do, and the mul, all in the correct order. So given this regular expression then, we should be able to see all of the values that are coming out of there. So let's go ahead and put this in another regex, static regex, mul with conditionals, regex. Oops. I wanted to do that. I like that better because then I'm not doubling up on anything. Okay, so that's matching our do's and our don'ts now. So we want a loop that looks pretty much exactly like this, except if our loop looked exactly like this, then we're assuming that everyone is a mul, right? So what we'll see here is a failure because we'll get 161 because we're not paying attention to the do's and the don'ts. Right. So if we look at the data here, let's go ahead and look at what the data. Whoops. Yeah, let's go ahead and look at what the data looks like here. Right. So our result here. Oh, no, sorry. Our match here looks like mol 2 and 4. That's good. So the value of the match is the whole match. That's useful. But we can also, we know that we can capture things, right? So the other thing we can do is we can capture the operator. So we can say we want mul, or we want do, or we want don't. Okay, so now when I look at my table, you can see that the match strings, we get a don't out here on 5 and a do out here on 4 and 3, 2, 1. That's kind of interesting, right? Because 1 is our mul. All right. So let's see what happens if I use that. Let's see what our matches look like. Oh, when we're looking with the wrong regex, by the way. I'm now realizing this is gray out here, which means, hey, nobody's using you. All right. I had expected the previous test to fail, and now I understand why it didn't. So let me show you how that test is going to fail now, because mul was not in the correct format, because we've now changed the regex. Okay, so let's come over here and we'll look at this. All right. Whoops. Let's run this. So our first match is mul 2, 4. And it's got, in its groups, it's got mul in the 1 group, right? And then its numbers in 2 and 3. So let's say if match groups 1 value is mul, then this needs to be now 2 and 3. Okay, so now we should stop failing, but what we should be doing is getting back 161 because we haven't turned anything on or off yet, right? And by the way, knowing whether we turn things on or off is important, right? So only do this when you're enabled. Else if match groups 4 value is do, then enabled is true. And we're going to go ahead and put this else if in here, even though we don't specifically need it, but I like it being explicit about this. And enabled is false. All right, so let's break here again and see how when we step through this, how this works. Okay, so let's put for watch, we'll put match groups 1 value, match groups 4 value, match groups 5 value. Okay, so this is a mul, so we're going to multiply these numbers. So our result is going to go up from 0 to 8. Now we grab another match. Now we're in the don't category, right? So 5 is don't. So we match here. Now we're not enabled anymore. Okay, so our next match is a mul, but it's going to miss here because we're not enabled anymore. So we're going to skip over all of these. That'll be fine. And then we have another mul, but we're still not enabled. So we skip everything. And we have a do, which should turn us back on. And now we have a mul, which we should pay attention to, which gets us to 48, which gets us our correct value. And so now our test passes. Okay, so this is a people don't necessarily think about regexes as being able to not only map multiple things like we did in the beginning, but also with this or being able to match multiple simultaneous things. So as a parser, like thinking about all the code you would have to write to correctly parse all this, I'm definitely interested in using a regex to help save time. And you can also pre-compile your regexes here. with an option, regex options compiled, right? And that will make them even faster. So that doesn't matter for us today, but there you go. And what is it telling me? Use generated regex attribute to generate the regular expression attribute and implementation time. Show the fixes. Okay. So convert to a generated regex attribute. I see. So this is the mul regex. And why are you upset? Okay. By the way, I like the explanation. I don't think I've seen that before. Partial method must have an implementation part because of accessibility modifiers. I don't really. Yeah, it's lying. Okay, there you go. We figured it out. So then we also turn this into a generated regex attribute here. There's going to be mul with conditionals regex. Okay. We throw this down here and it's upset and we just compile it and it'll stop being upset. Okay. So now we have our two regexes, all right? And theoretically, hopefully, we run this and everything will come back correctly. 48,161, oh, we're calling the wrong function, of course. Evaluate with conditionals. We got a number that was bigger. Why did we get a number that was bigger? That's a great question. That is a great question I actually don't know the answer to. Let's see. Mul enabled. Evaluate with conditionals. Oh, we probably need to preserve the enabledness across the conditional. Yeah, I'd forgotten about that. So let's do this for each var instruction and instructions. Match against the instruction. Okay. We don't actually have a test down here that tells us to do this. By the way, this can be a params. That will make our test happier. We don't have a test that evaluates this to ensure that it's correct. But I am curious to know whether or not this was exactly what we needed to do. Pretty sure it is. So what we're going to say is computer evaluate with conditionals, file, read all lines from the file name. I'm pretty sure that's what we need to do. Let's run it and make sure. Okay, that is. So one of the things that was unstated that is probably able to trip people up, and in fact tripped me up this time when it didn't last time because of the way I wrote it last time, is that your enabledness has to track across all of these things. So given that, should evaluate take instructions? A single instruction, and actually we should call this instruction, just to be similar. Or should it also take this to be the same, so that we have, a string array of all the instructions we want to evaluate? Interestingly, the other thing I want to talk about is whether or not we should collapse these things into one function. Because remember, at the beginning, I told you that it's possible we could write this as one function instead of two. So what would it look like if we wrote this as one function? We're going to call this old evaluate for now. And what if we wanted to write static int evaluate? We want to say bool support conditionals. And then we want params string instructions. What if we want that as our API? How would that look down here in terms of our tests? So we can start changing these tests. So can evaluate a single mul. Let's do this with evaluate. And then we can say, we don't care about you supporting conditionals for this. Can I get back 2? So that's a good first start, right? So instead of 2, we're getting back 0, because of course we're just returning 0. we could return 2. All right, you want to do this the fun way. All right, all instructions return true. 2. All right, and evaluate multiple mols. So here's where we're going to get into a little bit of trouble. So we'll say false here for evaluating the version with conditionals. We don't want to obey the conditionals. So here we're going to want 161. Okay, now we still have 2. So in theory, the easiest thing for us to do would be to come up here and say result, turn result. All right, and then we're going to do this, just like we did up there for each our instruction and instructions. All right, so that should now get us back to 161 because that's basically what the old code was. Okay, what else do we want, right? Before we even talk about conditionals, or should we do conditionals first? Let's do conditionals first. So can evaluate multiple mol with conditionals. So here we're going to put true, and we want 48, and this is evaluate now. Evaluate true with 48. And so here we can now have the case of 48 and 161. We want to bring up this logic where we now want to use the mul with conditionals regex, right? And we want this, but we're going to add a little bit of code in here. Basically says if support conditionals. All right, so we're going to put a support conditionals in front of each of these. And we start enabled support conditionals. So we'll only look at do and don't when we have conditionals. Okay, so now if we run this, now our tests are passing. So we obviously found a bug where we needed to have multiple lines. We could certainly test the multiple line version here. And the reality was we could have TDD'd our way into needing multiple lines instead of passing one line at a time here by realizing our mistake where the do and the don't continue across lines. So I think that's it, right? We can now get rid of old evaluate and evaluate with conditionals. We can get rid of our one regex. We can just call this our regex. Make regex. Okay. And then when we come down here into our final tests, right, we need to evaluate with false. And actually we need to do it like this because we need all the lines, right? So what we want here is we want evaluate false and evaluate true. And then we run everything and all of our tests are still passing. So that's an alternate where we have combined the logic all into one and used some conditionals to tell whether we're going to support conditionals. I did not intend that pun, but I'll take it. So now we have one set of code that is a little bit more complicated than our second function, but essentially the same as our second function. And we got rid of the first function and the extra regex entirely. So there you go. That's day 3 in a nutshell. Hope you enjoyed this, and so far so good. Please come back tomorrow for the next day. Thanks.